live from Twitch TV, and we are back. And going to continue on with our socket networking stuff. And what I wanted to add, if we run our mixed test here, you'll see that the test won't run. Weird. Mixed test. There we go. We'll see that the test will halt waiting for our integration test to run. And we don't want this to run every time. So what we're going to do is we're going to edit the integration test such that we will only run our integration test when we request it. So what we do is on our test, we tag it with integration as an atom. So now, if we still run it, it'll still do it. We need to do one more change. We have to go to the test helper, and we need to set the exclude. We want to exclude the integration tests. Exclude. Now if we run our tests, it'll run everything but the integration tests. Now if we want to run the integration tests, we can actually just pass a param to it, and then, I spell it, integration. So now it'll actually run the integration tests, and then we have to run our integration tests on this end. So that'll give us a little bit control over our tests, and we won't need to run our integration test every time because it's a little bit of a manual process. So just wanted to add that in. So we're going to just commit that status. So git commit -a-m added flag for skipping integration tests. Okay, so now we're going to go to our net socket, and we're going to finish out the. So we got the write. Now we need to do the read. So what we're going to do is we're going to test should read Boolean from connected socket. And what we're going to do is, technically, if the socket isn't connected, it's kind of a weird thing because we don't want to just return nothing. Could throw an exception. Let's sort of think this through here. So socket stream read Boolean, and look at this, assert is true and assert is false. Oops. And what we need to do is we need to do a input this time. Read. I don't think we have our input. Input. Is it going to ask us for, there we go, and input. So now we have our input ready to be mocked in. Input read byte. We'll do 1, and then I forget what it is, the syntax. So let's do this. Returns. Is there a then? Actually, I need to do this. returns 1. And then I think we did this in the past. Or then, no. Let's try this. We're going to say returns and then dot. Let's do this. Let's try that out. So what we're going to do is we're going to run it. And what we need to do is we need to edit our test HXML to take out our integration tests. Okay. Close everything else. Others. So now we have one failed, which was this, which we expected. So read Boolean. I'm going to do input, read byte, and equals 1. Oops. And that passes us. Perfect. I can add one more test just to make sure that it wasn't just a coincidence. Oops. Okay. Too loud. It's too loud. Okay. Test should read byte from connected socket. So the interesting thing here is if we are not connected, we should probably throw an exception. So test should not read data from socket that is not connected. So we probably need to do this here. And I think what we should do is we should do socket stream read Boolean, and we should try it. Try. And if that fails, it is true. Actually, I think there's just a fail. Yeah. Socket must be connected. Catch the dynamic, and we'll search true. True. So now we should have 2 failing tests, and we're going to make a nice little convenient function here, which is check connected. Like inline function. If not connected, throw socket is not connected. So now, oh wait, we didn't get any failures. Why didn't we get this? Why didn't this fail? Oh, because that would not throw an exception. So, pretty. read byte throws a mess. I would just say error. That seems better. So now it should fail. Well, it should fail. Does not fail. Why doesn't it fail? Oh, probably because we need to. Is this an exception? And so it should be this way. Should throw the exception. There we go. We got it backward. There's our fail. So now we say check connected, and we should be ready to go. Oh, guess not. Should not read data from socket that is not connected. Oh yeah, because it's going to throw an exception either way. Okay. We don't need that. So let's see here. So read Boolean. So it was correct the first way. Darn it. There we go. Okay, so continuing on. So we should say connect to socket, input, read byte, which it already technically works. We'll do 32. Oh no, returns 32. Assert are equal 32 socket stream read byte. So now check connected, input read byte, done deal. There we go. Test should read double from connected socket, connect to socket, input read double. Do we know how to? Oh. Read I forgot why. Read all, read full bytes, read until double. Get double sig. Read, there is a read double. Read double, big old scary number. And I keep doing this. Returns. There we go. Insert are equal, big old scary number, socket stream, read double. Watch it fail so we can make it succeed. There we go. Input, read, double. There we have it. Fast test. Should read float from connected socket. Connect socket. Input, read float. Returns some strange floating point number, negative that. Assert. really sort of boilerplatey code here, but it needs to happen so that we have good test coverage. Test should read flowed. That's a word, right? Flowed. Should read int from connected socket. Input read int 32 returns a fancy number. Assert are equal read integer connected input read int 32, and we're going to read a short. Test should read. I think we had unsigned short. Probably should go both ways. Unsigned short from connected socket. Unsigned short, there it is, okay. Connect socket, input, read, int 16, returns 128, or equal 28, socket stream, read, unsigned short. Was it 16? Thought it was. Should write unsigned short, and it is right unsigned short. Right. Okay. So it's uint 16. Uint 16. Check connected. Input read uint 16. And actually, what we're probably doing wrong here that I totally skipped is we probably need to read this off of a buffer. Oh no. Oh no. Didn't catch that. We need to read this off of a buffer so that we can get the bytes available. Darn it. Alright. Backtracking here. And we also need to subscribe to the data received. So we're going to need that regardless as well. So that was fun. Now we have to undo it all. Okay, so actually these tests are still valid, but the input stuff is not technically right. So what we need to do is we need to do socket stream update. And so what that'll do is that'll pull it off the buffer. And then we have to assert are equal that we have 3 bytes in the socket stream. Bytes available. Baby, smell great. Babe. Babe. You smell great.
Huh?
You smell great.
Thanks.
Alright, so now this will fail. And this is not totally true. So what we need to do is have a buffer. So let's take a look at what Hex can provide for us on our buffer. We could use, it's a single. Okay. Check out sys. We've got our socket. We've got our input. Okay, so Hex IO. Let's take a look at that. All right, this looks pretty good. Array buffer view. And that's byte length sub array. No, let's create a new one every time. Buffer input. And that one we're going to have to create a new one every time. Not that thrilled about having to keep creating. So this looks promising. So the length of the buffer in bytes, we can add byte, add bytes, add double, add float, add int32, add int64, int string, and then get bytes. Returns a copy or reference of the current bytes once called. The buffer can no longer be used. That's probably okay. So we just need, let's just get bytes though. That's all the bytes. That's not that great, is it? Bytes input. This one here, extended by string input. That doesn't let us get a byte. Darn, that bytes buffer was our best bet. Let's take a look at it some more. Buffer input is refilled and tells anything, does it? Position input, we have to input the buffer. The downside is we have to keep, I wonder if we could manhandle the bytes. Let's get set. So we could allocate some bytes. Behavior when reading outside the available data is unspecified. Okay, so we got bytes and bytes buffer. And wait, what is it? Refresh and bytes input. Bytes data. It's not useful. Buffer input. So if we input the bytes, having a hard time keeping this all in my mind. I could just do bytes, it looks like. So we could allocate a bunch of bytes. And then we can read and write to them. So let's see if this works. So we're going to create a buffer. BRV, we'll call this buffer. This is bytes. And what we'll do is there is a length. That looks pretty good. So on our, how about on our connect? On our connect, we'll create our buffer equals bytes alloc, and we'll get 1024 bytes. I think that seems reasonable. and we don't want to fetch more than that. And then our update, we're going to take our input, read all. Read full bytes. So what's up with the input? Where is our input? We just want input. There it is. Read all. So we could just read all. Let's try it. Its default value is target specific. So read all. Read all, the buffer size is 16. So, okay. It looks like it's going to do this anyways underneath, which is kind of dumb. But we'll make sure that we don't do the same. So read all, and this will give us bytes. And let's take a look here. We're not using, are we using bytes? Yes, we are using bytes. So if we get bytes data, which doesn't do anything. Alias for array unsigned char. I wonder if we could just use this directly, because we're getting it anyways. So let's just do the buffer, and then we don't have to allocate it. I think that seems reasonable. And now our bytes available where is it at? Bytes available is no longer var, it's buffer length. That seems reasonable, right? Am I crazy? Doesn't give us much detail here, but it seems plausible that the buffer length would be the length of the data in the buffer. If not, we're going to have to figure something else out. But let's go with it for now. So now we can write a test here. Actually, I think I'm going to put this somewhere else. I think the problem with this is that if we keep getting updates and we're not reading it off of it, that's the problem. If we keep reading it, read all, and we keep overriding our buffer. So unless we read the entire buffer in one single update, we'll lose our data, and that's bad. So we don't want to do that. So let's go back to bytes available. Actually, no, we can just keep that for now. So we do want to allocate our buffer. Bytes alloc. Let's do 1024 for now. And we're going to read all, which is bytes. And let's go back to here. So isn't it beautiful?
Thank you.
Love you.
Okay.
Me too. Okay, so If we get at position 0, and then we set at the position. Of data. Now shows a little bit more detail on this. Because I wonder if we could do the bytes data of data. Let's try it and see what happens. It's going to be up to our integration test on this one. And so we're going to do read all, that's our bytes. And so we're going to do bytes dot of data input read all of that of data read all I think that doesn't change anything, so we don't want to do that. Okay, so still not liking the approach here. So the alternative is setting the position, which is technically bytes available. So, oh weird, I have this open? Okay. So read all, this is bytes. We could just read byte. Okay, let's try read all. Let's get the bytes. What if we do read byte? It'll actually do a read into file and just crash the program. So what we're going to do is we're going to say while bytes get no, I probably should do a for loop. So for var I uint equals 0. Oh, that's not how you do for loops in Hack. So for I in 0 through bytes dot length. Buffer dot set position, which would be bytes available, plus I, and then the value would be bytes get at position I. And so that should give us bytes available is equal to buffer dot length. So that should do that. So now this turns into input read all returns, so we need var bytes equals bytes lock we need 3 bytes set 0, 1 actually do index equals 0. Let's do I plus plus, I plus plus, and that one's going to be 0. Read all returns bytes. And so now we need to comment these guys out because now those don't make sense at the moment. Let's see how this pans out. And that's going to be, so the integration, see if that does the trick. Bad import. Okay, so we have value 1024. So is there still a line 183? Ah, okay. So we need to do, so our buffer length is always going to be really, really high. So we don't have a way to set up. What's interesting is that there's no get where it actually chomps it off, and that's not that great. So let's take a look at our input again. Bytes input. So we create a new bytes input, length of stream and bytes position, and length. But that doesn't do us much good because we don't know for sure if it chomps it off. Darn, a ton of trade-offs with this that I don't like. It seems almost better just to use a list. But we're not there yet. We haven't gone that far. Because the buffer length is always 1024. We could reallocate the bytes. We could do this. Bytes, our buffer equals bytes alloc. Every time we get an update, we're going to lose it. That's not going to work. I feel like we need to do some testing here because we don't know for sure if when we get the buffer that it actually takes it off the buffer. And I'm betting it doesn't. I bet it stays in the buffer. So if we keep getting 0, we'll get the same value every time, I'm guessing. So let's see here. What we could do I think. Thinking. Running out of time thinking. So I gotta get to my day job. Compare. So this is kind of our biggest point here. So if we just stick with the buffer, all will be okay. Oh, I think we can actually test this, actually, now that I think about it. If we... okay. I'm gonna run update. I'm gonna do this. Let's try this. Okay, so buffer bytes allocate bytes dot length Now we still lose the bytes, but yeah, this is what we want to find out though. And now when we read them, read Boolean buffer we're going to do bytes available it's buffer at length. Okay. I'm going to just do I for now and see what happens here. I 183. Buffer has no read byte. Oh, dang! This is so janky right now. Buffer get 0. So it does fail. What does it say? Expected false, but was true. So yeah, it is getting the same byte. So it's not actually chomping it off. So now our buffer I wonder if we call this our input here. We do have an input. We can take this off. This will be socket input, and I wonder if we do our input equals new. Let's do this here. It's a little bit of a playtime right now, just because I'm unsure how this is going to work. Bytes buffer? No, we want the buffer input. Bytes input. Bytes input. New bytes input. That also isn't great. So we're trying to call update bytes and this is going to be a bytes input. input is input length. $183. Input. Let's see what this does. So that one does succeed. And I'm actually kind of impressed by it. The downside, you have to create new bytes input every time. But what we can do, darn it, that's kind of worse. Why do I have to create a new one every time? I don't like that. So what we need to do is we need to put this here for bytes length. We do our buffer darn, this is just so janky. There's got to be a better way. Creating a new bytes input every time with a buffer, it's just not that great. Bytes buffer. It's just not that great. So if we use the bytes buffer and add bytes, which is not too different than what we're already doing here, so it doesn't do us anything. This is kind of dumb. If we do the buffer input, what does that gain us? Buffer input, let's try that. Buffer input, is that what we're already using? Bytes input, buffer input. Okay, buffer input requires an input, bytes, position, and available. So sort of input, why do we need an input? Buffer input. So if we give it the buffer, so input equals new buffer input, do the socket input and the buffer. Okay. And we do input available, and here we read all the bytes, put it on the buffer. It doesn't say it's read only, so we do input dot buff input dot buff. So that just breaks. And we don't know where it broke. I don't know why we need an input. That seems so weird. So let's try this. We're going to try new bytes input. That seems ridiculous. New bytes input, and it needs bytes. This just seems so, should be way easier than this. So that crashes it as well. So this thing is moot. I mean, we can do it where you create something every time, which I'm just not a fan of. So, actually, no, we can do. I think our buffer. Let's try one more attempt at this. Bytes alloc 1024. Okay, so that didn't crash. Let's try socket input. Let's see why it would make a difference, because we're reading it off. Yeah, by 0. So this is input available is not getting the data. So if we do input buff length, that's probably going to do 1024. Yeah. So input available. You would think this would work because we're talking to the buffer, but it doesn't. It's just not that fantastic, and there's no way to know. Documentation on this is pretty slim. Buffer input. The fact that it has a position is a concern. Looks like if we did is available, we could just do input available equals 3. I bet it would be the same. Doesn't actually manage itself. Yeah. But it did read it in order. That was surprisingly beneficial. So we do bytes dot length. So that actually works. It's better than what we had. So I wonder if we can do this. If we read twice, and then input read all again. In this case, we're going to do a different set of bytes. Read all, and this should be, let's reverse these. So false then true. Let's allocate 2. And actually this is going to be true, false, true, like this. Because we have these 3 bytes it's going to read, and then we're going to have 2 more bytes, so we're going to have 5 total. And what we're going to do is we're going to have, search bytes available, should be 1, should be 4, no, it should be 3. Okay, so we got a failure. This value was 1, not equal expected 3 on 193. So what we need to do is we probably need to set this to a variable. Bytes available, input available. We could do input available plus plus. See if that does it. Nope. Value 1 is not equal to 3. 193. Bytes available is input available. Let's just trace this. Input available. Once we get this, it's basically done. Done deal. So it's 1, 2, 3. Value 1 is not equal to 3. Bytes available. We didn't call update again, that's why. So read all. So socket stream dot update. So this is saying it's 4 on 194, which we probably need to do something like this. Where's our read byte input available minus. So we're going 1, 2, 3, 2, 3, 4. Is that correct? We're allocating 5 bytes total. We're going to read to, this should be, so let's see here. 3, 2, 1, add 2 more, should be 3. So 1, 2, 3, 2, 3, 4. So why is it reading 3 more? Trace input available. Okay, so it starts at 0, goes to 1, goes to 2, goes to 3, and then bytes available is 1 because we've read twice. I wonder if we need to do input reset. I think that's the problem. It keeps reading off the same mock here. Expected true, but was false on line 198. So it should be true, false, true, false, true, but it's doing false, false. So what we need to do is we need to do I plus input available. Still failed. 196 is true. I just don't like the way this is working. I'm also curious, trace buffer length. Buffer length is always going to be the same, so that's not going to work. Get data? Give us anything? I gotta get out of here. This is frustrating. I wonder if it gives us nothing. So at least we're getting the right number of bytes. I wonder if we can do input buffer get I need to put that here though. So now, this is impossible to read. So we have 0, 1, 0, wait, 1, 0, 1, 1, 0, 1, 0, 1. .196 expected true but was false. I feel like it's reading this byte and not this byte. For input buff trace input buff get I. So here we want input available. So line 105, we go on 100, and that's not what this is supposed to be. 100, This is ridiculous. Getting really frustrated with this. Because it's writing 101 here. And then when you read it in order, 1, 0, 0. Wonder if we just do 0. If it chomps it off. Nope, it does not. This is super irritating. So if we set, what we'll do is we'll get val bytes get I trace val. Getting really, really irritated about this right now. That we're not getting. So here at line 101, we're getting 101, and at 106, it's not the right thing. And then 101, we write the two correct, 0, 1. This is still wrong. Still, you're wrong. Alright, I gotta go. I'll have to figure this out later. This is frustrating. Okay, so not much to prove yet. We are dancing with our update function. I'm gonna try and fix this over the weekend offline. So, alright, I'll see you guys on Monday. We'll get this cleared up, promise. Alright, see you.